Everybody knows that Red Bull gives you wings, but who gives Red Bull wings? And why? Well, the answer to that first question is a big team of engineers sitting in an office in Milton Keynes, may God help them. The answer to the second question though is a little bit more complicated. First, we need to talk about a little bit of physics to understand what's happening around a wing, and then we can start to look at the design of cars and why wings look like they do. Welcome to F1 Explained. Like and subscribe, you know how it works. Let's talk about wings. So firstly, we need to understand what the air around a wing is actually doing and how it's generating force. Now, you may look at a wing, a solid object sitting at an angle to airflow, and assume the air is just hitting the top of it and bouncing off. Newton's second law of motion, all actions have an equal and opposite reaction, air go up, wing go down, right? Wrong. Well, mostly wrong. While it's true that air is a bunch of little particles and some of them are slamming into the wing, this isn't really what's generating the force that's pushing our car into the road to generate grip. Instead, if we think of air as a continuous stuff that flows around the wing, we can see from the shape of the wing how the airflow gets transformed. The airflow is getting turned around the wing in order to flow along its curved shape, and things will only turn if there's a force acting on them in the direction they're turning. So, for this air down here to turn upwards, there must be a force acting on it at 90 degrees to the curve. And if there's a force acting on the air, then there must be an equal and opposite force acting on the wing, pulling it downwards. So, whenever the air around our car is turning, there's a force acting on the car directly through the curve of this airflow, from the inside to the outside. Curves bending towards the wing are low pressure, and curves bending away from it are high pressure. If we have an overall lower pressure on the bottom of the wing than the top, downforce. One other important thing to consider. You may intuitively think that most of the force on a wing comes from the high pressure air on top of it pushing it down, whereas actually it's the low pressure side pulling it down which gives us most of our downforce. On a well-designed wing, the force on the underside can be 2, 3, 4 times as much as the force on the top, if not more. For that reason, the most important thing an engineer can do is to design their wings to give clean, low pressure flow along the bottom. Obviously that's on a car. If you're making a plane, that's generally bad advice. So, you've probably seen that if we cut through the middle of a wing, the shape of it is something like this. But why? Well, let's start with the most simple wing we could make, which would just be a rectangle at an angle to the airflow. The first issue with this is the sharp corners at the front. Our air can only turn so fast, and in this case, we're asking it to make a 90-degree turn almost instantly. The air looks at this and goes, nah, and just leaves. We call this separation. The wing and the air have to separate at some point, but generally it'd be better if this happened at the back of the wing, so the air can actually do some work before it gets to that point. If we round off these sharp corners, it gets a little bit easier for the air to stay attached, and therefore our separation point moves backwards. Nice. But we can do better. The air needs some time to get attached to the surface of the wing. We can't just ask it to turn upwards straight away. So, if we start off a flat portion of our wing, a horizontal portion, and then gradually curve upwards, the separation point moves even further back, as the air can much more easily stay attached to the surface of the wing. Remember, force equals pressure times area, so the greater the area of the wing that this flow is staying attached to, the more force we are generating. So we've rounded off the front corners, and we've made the start of our wing horizontal, and really actually, this is the shape that most automotive wings follow. If we clean this up and make everything as smooth as possible to prevent the air from getting separated, that's our wing shape. So from here, what can we do to make even more downforce? Well, first we can increase the angle of attack, the angle at which the air sits relative to the airflow. The steeper this is, the more the air has to turn around our wing to get from the front of it to the back, and if it turns more force generated. But, as before, if we ask our air to do too much, the air is just gonna refuse and leave. If we get separation from increasing the angle of attack too much, this is called stall, which will massively decrease the amount of downforce we're generating, which is bad. So we want to increase our angle of attack a bit, but we don't want to do it too much. We can also increase the length of our wing in the direction of travel. This is called the chord. The longer the chord, the more surface area the pressure has to act on, and therefore more downforce. If we look at an F1 wing, we can see it's not quite as simple as the ones we've been talking about so far. There are some other little bits which we can stick on to increase the downforce even further. We can stick an end plate on our wing, which basically just works to keep the air where we want it. If we look at the tip of our wing without an end plate, we have high pressure here and low pressure down here. As air wants to travel from the high pressure zone to the low pressure zone, it just will do that. There's nothing stopping it. This obviously decreases the performance of our wing because it reduces the pressure of our high pressure zone and increases the pressure of our low pressure zone, which are not good. So if we literally just stick a wall in the way, then the air can't travel from the top to the bottom anymore. And this is called an end plate. End plates can also be very useful for generating vortexes, which are good for both conditioning air and reducing drag. But we will look at both of these in future videos. As we said before, if we crank the angle of our wing up too high, the air on the suction side is just gonna quit and separate. But if we really need a high attack, high downforce wing, what can we do? Well, if we cut a little hole through our wing from the top to the bottom, some of the air from the top side can now flow through to the underside, take up the place of the air that's separated, and continue to work the suction side of the wing. As we split our wing into multiple bits, this is called a multi-element wing, but it basically still acts as one big wing, following the same profile of all these multiple wings added together. You only need to do this on very high attack applications, because while the surface separation is better of the multi-element wing, the overall downforce will be lower than having a single element wing. So if you can use a single element and the flow stays attached, then you should do that because it's better. We need to hold our wings up somehow. F1 wings are partially supported by their end plates, but they also have a strut in the middle to increase the support and also reduce the rotating and flexing of the wing. So we need to hold our wing up in the middle, just have a strut coming up, holding the bottom of it. Simple, right? Well, not so much. As it's so important not to interrupt the airflow on the bottom of our wing, it's actually better if this strut bends up and over and attaches to the top of our wing, leaving the bottom as clean as possible. This sounds like quite a basic thing, but it does make a pretty significant difference. And so after all of that, we now know how to make a good wing. So the question is, where do we put it? Well, we know that modern F1 cars have two wings, right? One at the front and one at the back. But can they have more? No, they can't. History has shown us that if the teams could put more wings on their cars, they definitely would. But the FIA does not like this, and so the teams are only really allowed to have a front wing and a rear wing in pretty controlled areas. From time to time, we have seen the teams try to be sneaky and turn other things into wings. Suspension elements, side mirror holders. The teams will try whatever they can get away with, but in most cases, the FIA clamps down on this pretty quickly to prevent us from getting more X-Wing cars. So okay, we've got a front wing and a rear wing, and a little bit of freedom, not much, to decide where they go. Where should they go? Well, we want to stick our rear wing as high up in the air as possible. As it's at the rear of the car, it has to deal with air which has already flowed over lots of other things. Wheels, intakes, Nikita Mazepin's forehead, all things which make the air less effective for generating downforce. So, the higher we can stick our rear wing, the less of this disturbance it has to deal with. On the flip side, we generally want our front wing as low as possible. Any aero device close to the floor will benefit from ground effect, which we will cover more in the next video about floors and diffusers, but basically, the closer you are to the floor, the stronger this effect is, and the more downforce you can produce. Within reason, obviously touching the floor, not great. If we look at racing classes with less restrictions than Formula 1, we will start to see some of these principles in action. Super low front wings, or front splitters, front diffusers, whatever you want to call them, they're all the same thing really, and super high rear wings. Formula 1 claims it controls where teams can put these things for safety reasons. And while that's partially true, because pushing designs to the absolute limit could make cars which are extremely unpredictable and difficult to drive, I think it's fair to say as well that they are trying to maintain a certain aesthetic for the sport. Because again, as history has proven to us, if the teams need to, they will make their cars mad ugly in the name of performance benefit. And that's it. Wings in a nutshell. Next time, we will take a look at floors and diffusers and find out what ground effect actually is. People keep saying it, but I don't know what it means. Well, I mean, I do. And so next time, I will teach you what it means too. Make sure you hit subscribe so you don't miss that. And like this video too, if you liked it. And until next time, stay safe, and I'll see you guys later.